Hello and welcome to another video. In this video I'm going to be showing you what you need to do to sketch a curve. Now there are all kinds of functions and curves you'll be expected to sketch in calculus. I have been able to devise what you call an acronym for you to remember the things to do so you can get the maximum score, and also so you don't miss anything out on the curve that you're going to sketch. So I'm going to do all of them. I have 3 examples that will cover virtually everything you need to know about curve sketching, but it looks like I'm going to make 3 separate videos. So if I end up breaking this to be video 1, know that there's going to be a video 2 and there's going to be a video 3, because these curves are completely different. For example, this curve has no vertical asymptote. This one has a vertical asymptote and also has a slant asymptote. This one has no asymptote, but there's a lot more work to do here because of the roots that you need to get. So, so far you can see that instead of you following the A, B, C, D, E, F, G, I've seen that in textbooks, but people don't remember what's in F or what's in G. Okay, but this one helps you because D will be the domain of the function. This is the intercepts, the x and y intercepts. This is the asymptotes, and these are the limits you need to take. These are the extremas, that is the maximum or the minimum. This is concavity test. This has to do with the trends, which means the regions of increase or the regions of decrease, and this is symmetry. So you see, if you remember dialects, you should be able to sketch a curve. Let's take it. The domain of a function, because it's a rational function, ideally you expect every value, every real number on the number line to work, except if there's going to be a problem with the denominator where you're going to get 0. But the way this looks, we're not going to get 0 because whatever you add to 1 will always be greater than 1, or at least the worst that could happen is if it's 0, it's going to be 0, and it's not going to be negative. So virtually no vertical asymptote, we don't have a problem. So you say domain, okay, in this case will be all real numbers from negative infinity to positive infinity. Okay, that's all you need to show. Everybody can see that. You move on to the next thing you require. So it means when you plot the graph, your graph is going to go all the way from the left to all the way on the right. So that's the first thing. Now the next one will be the intercepts. Okay. So first we want to talk about the x-intercept. The x-intercept will be, or let's take the y-intercept first, will be what you get when x is 0. So all you have to do is plug in 0 here, okay? Plug in 0, that's going to be 0 divided by 0 plus 1. So it's going to be 0 over 0 plus 1, which is going to give you 0, okay? So the x-intercept will happen at the point 0, and y also will be 0. You see, we plugged in 0 for x, and the function itself gave us 0. So that's the the x-intercept rather. So what will be the y-intercept? It will be the point when this function is equal to 0. And remember, when a rational function is equal to 0, it's only the numerator that's equal to 0. So when x squared equals 0, x must be 0. So we can also do that and say x squared equals 0. That means that x equals 0. So that's the point 0, 0. It's the same point as this, okay? 0, 0. It means that the x-intercept and the y-intercept are the same, and they're at point 0, 0, which is the origin. So you quickly go to the graph and say that you know that your point, this point has to be on the graph because it's both the x-intercept and the y-intercept. We'll move on to the next thing. The next one is the asymptote. Okay, as you can see, there is no asymptote in the case of this function because there is no value of x that will not fit here, or there's no value of x that will give us a 0 in the denominator. How do you prove that? You can actually say equate the denominator, x squared plus 1 equals 0. that means that x squared equals negative 1. Well, as long as you're dealing with real numbers, you can solve this and get a real number because you're getting x equals the square root of negative 1, and that doesn't work. So you say no vertical asymptote, no vertical asymptote. Okay, if you don't have a vertical asymptote, can you have horizontal asymptote? So we go to horizontal asymptote instead. Horizontal asymptote. So the degree of the numerator is 2, the degree of the denominator is 2. Now when they have the same degree, there's always a horizontal asymptote. And the horizontal asymptote is the ratio of their coefficients. Okay, so if n, which is the ratio, which is the degree of the numerator, is equal to the degree of the denominator, remember the degrees will be the highest power of x in each of the numerator and denominator. So it's going to be the coefficient here, which is 1 over 1. So we write as 1 over 1, which is equal to 1. Okay, so at this point you say that the horizontal asymptote is y equals 1. That's the line. It means there's going to be a horizontal line running, okay, across that prevents your graph from crossing. So we can as well just choose this point and say this is the line y equals 1, and then we have a horizontal asymptote. I hope that is relatively horizontal. Okay, so that's what you're going to have on your graph. We're done with that. Let's go to the limits. I may have to erase the board, okay, so I can have enough space to do the limits calculation. Let's see how it will behave, and then you will see that it's relevant to what we just did. Sometimes you don't need to do this, you just need to take the limits and you can tell if there's an asymptote or not. So the first limit you want to take is that of the function as x goes to infinity. That is, as you keep going this way on the graph, how will the graph behave? Because that will help you sketch, okay? How do you take limits? The best way to do that is divide the top and the bottom by the highest denominator that you have here. So we're going to say this is the same thing as the limit as x goes to infinity of x squared over x squared. You know, I'm just going to do it here. So divide by x squared and also divide this by x squared. Okay? If you do that, this is going to be 1 over, this is going to be 1 plus 1 over x squared. So as x goes to infinity, this is going to become very large and makes this 0. You end up with 1 over 1 plus 0, which is equal to 1. So what happens is, as x continues to increase, the function will be approaching 1. Remember that 1 was what we said was the horizontal asymptote, this number. So your graph will be approaching 1 as it is going away. It's approaching 1. Now whether it's going this way toward 1 or this way toward 1, we don't know. We're going to figure that out as we keep going. Okay, but that's as it's going to the right. What about if we switch it to the left? Okay, if we switch it to the left, it's the same thing you're going to do. The only thing is that your infinity will now be negative infinity. We change it here also to negative infinity. And let's see what happens. If you plug in negative infinity, this is going to be 0 also. Doesn't matter what it is. And you have 1 over 1. You still get 1. So it's going to be the same thing whether it's positive infinity or negative infinity. It means on both sides you're going to have this. Let's do something. Another point I wanted to make is that you don't have to follow the order, okay? You can start from whatever you know you can do. Somehow you get some of the points, even if you don't do everything, okay? Let's take the symmetry test, okay? Symmetry test just tells us that it's going to be even if I change x to negative x, the function doesn't change, then it's an even function. But if I change x to negative x, and the function becomes the negative of itself, then it's an odd function. Now, if I put negative x and the function completely changes, then it's neither even nor odd. So let's quickly see. Let's test for whether it's even. We're going to say f of negative x will be equal to, we're going to change this to negative x, that will be negative x squared over negative x squared plus 1. This gives us x squared over x squared plus 1. You see? It's exactly the same. So if you switch x to be negative x, what happens is you go back to the original function. So this is an even function, okay? So once you found out that it's even, you don't need to do any more tests. That's usually the first test you start with. Now if it's even, you do it. And this even function means it's as if you place a mirror on the y-axis and one side is just the image of the other side. So however this side behaves based on this decision now is how this side will behave. So you can just focus on one side and then you just recreate the image on the other side. It also helps you see what you plotted to see is this exactly like this side mirrored, and that's a good thing. Now let's go to, so we're done with the limit as x approaches infinity, so we can write here and say that, let's write limit, okay, and say that the limit as x goes to positive or negative infinity of the function will be equal to 1. We're just going to put it that way. Okay, so now we have three parts that we need to deal with. Now you see these 3 parts, you can take them in any order, but because you have to do differentiation. Now this is the part I'll need to erase the board. I'll take you through each of them and what to do with all 3 of these. This one is the extremes, the maximum and the minimum. This one has to do with concavity test, which part concaves down, which part concaves up. And this one is what part is increasing and what part is decreasing. So we take these 3 together every time you do it, but it doesn't matter which one you do first as long as you can do it first before you do the test. Okay, for us to start any of these 3, let's just tell ourselves we need to differentiate. Okay, so you have f prime of x will be equal to, we differentiate this function using quotient rule, which is this x squared plus 1 du dx, which is going to be times 2x, minus, you keep this x squared and you multiply it by, you differentiate this, that's going to be 2x, okay, all divided by x squared plus 1 squared. So that's the quotient rule, okay? Let's simplify the top and get our answer. So this is going to be, you can actually take out, let's open it up, that's going to be 2x cubed plus 2x minus 2x cubed over x squared plus 1 squared. Well, this is going to take this out and you're left with 2x, okay, over x squared plus 1 squared. So that's what you get. There's no further simplification you can make. So what do you do with this? Well, at the critical point, okay, at the critical point, you know that the derivative of a function will be equal to 0 because the rate of change becomes 0 at that critical point. So this is going to be equal to 0. So if we equate this to 0 at critical point, if this function is 0, it simply means 2x equals 0, which implies that x equals 0. So the point x equals 0 has become a critical point now. Okay? The point x equals 0, something happens at point x equals 0. Okay? So how do we know what happens? That is where you need to do your trend test. This is a good method. What you do is draw the number line and mark this point to be 0. So you want to ask yourself, what is happening to the slope? Remember, the slope is what we just got here. What is happening to the slope before I get to this critical point 0? Remember, we told you something happened at 0. So it's either a maximum or a minimum that happened there, but we don't know. And since there's just one point, let's just test it. What happens before you get to 0? Well, all your values of x will be negative. So let's choose any negative number that can work easily. I'll choose -1. It's easy to work with. So put -1 here. 2 times -1 will give you a negative answer, okay? And this will give you a positive answer because no matter what's here, when you square it, it becomes positive. So it's negative number over positive, that gives you a negative. So the slope at this point is a negative slope. And a negative slope looks like this. It comes from this way. So you expect this side to go this way. Okay? Now let's test what happens after you go beyond 0. If you take a number after 0, it's going to be, a good one is 1, and you put 1 here, your top answer is going to be a positive answer, and this is always positive. So positive over positive gives you a positive answer, and you have it this way. So some people use this to represent it and make this side negative, negative. I like to draw the line because it gives me a picture of the shape of my curve, because this is going to be the shape of your curve when you put it there. So now, if something goes from this, changes from negative to positive, this must be a minimum point. It cannot be a maximum point. Okay, that's how I kill 2 birds with 1 stone, not 2 stones with 1 bird. Okay, so this is going to be a minimum point. And here, you have solved these 2 together. So you talk about your extrema. Okay, it will be a minimum. Minimum happens at the point where x is 0. And what will y be when x is 0? You go back and plug in x here, so you know what the function will be. 0 over 0 plus 1 will give you 0. So this point 0, 0 is the minimum of the curve. Okay? Now our curve is beginning to shape up, because now the only thing we need to figure out will be the concavity. Concavity just tells us, you see the way this is our curve going to be straight lines? Well, we know this is not a straight line. It's not a linear function. Okay, a linear function would be y equals mx plus b, but this is not it. So it's going to be a curve. We just want to know, will our curve be like this? Or will our curve be like this? The concavity is what tells us whether we're choosing this and then this, or whether we're choosing this. You don't know how the curve could be, okay? We want to know if it's going to concave up and concave up, or concave up here and then concave down. That's the test we're about to carry out, okay? Sorry for messing that up. Let me clean it up. Okay, I did clean it up. Now, let's test for concavity. The problem with testing for concavity is that you now have to look at this and differentiate it again, because concavity is based on the second derivative. So don't forget, when you get your first derivative, make it as simple and clean enough. Don't leave it like this, okay? So that you can differentiate this again. So let's differentiate this so we can get our critical values for the second derivative. Okay, so I was able to transfer all the information that we already obtained to this side. We can refer to them later. Remember, you need to show your work, keep your record, and then these other things we need to sketch our graph. We're almost done. So at this point, we want to differentiate this, okay, the second time. So we're going to have f prime prime of x. We follow the same rule. It's going to be x squared plus 1 squared times 2. If you differentiate that, minus, you keep the top now, 2x times, if you differentiate the bottom, it's going to be 2 into x squared plus 1. And multiplied by, you differentiate the inside, it's going to be 2x. Okay, all over, you know, I'm just going to put it on the side to save space, all over x squared plus 1. If you square this, it's going to be to the 4th. Okay, so let's leave that out. So this is equal to, remember all of these will be divided by that. Now if we simplify what's inside, we can take out x squared plus 1 actually. It's going to be x squared plus 1 into, what's left is going to be 2x squared plus 2 minus, we've taken this out, so we're left with 2 times 2 times 2, that's going to be 8x cubed actually, no, 8x squared, 8x squared, okay, all divided by x squared plus 1. Now let me write it this way. So it will be divided by x squared plus 1 to the 4th. As you can see, this will take out one of these, and when we simplify what's inside, your answer is going to be 2 minus 6x squared over x squared plus 1 cubed. So that's what you get for your second derivative. And with that, you need to equate this to 0. And remember, when you equate a rational function to 0, the numerator is going to be equal to 0. Okay, and then so we say that 2 minus 6x squared equals 0. If you solve this, you're going to get x will be equal to plus or minus the square root of 1/3. Okay, so you're going to have two answers. So you're going to have, we're going to do the concavity test too. So, which means you have 0. Remember, 0 was a critical number. And then you have negative 1/3, negative 1 square root of 1/3. Now, getting the exact value of this doesn't matter. You don't need it. You're sketching. Remember, you're sketching a curve. And this is going to be positive 1 over square root over 3. That's square root of 1/3. So all you have to do is just think of a number. You want to see what happens, okay, at certain points. What changes? You will notice that you don't really have to recognize the 0 because we already know what's going to happen at 0. Let's just look for numbers between here and here. What's happening between these two regions? Okay, what's happening here? So a good number to substitute obviously is 0. Let's start with the one that's easy. You're going to plug in 0 to the answer you just got. Okay? Don't plug it into this or this. You're plotting it in because you want to see the behavior of concavity at that point. Now, so you plug in a number between these two, which is 0. Plug it in here. If you put 0 here, everything here becomes 0. So you have 2, which is positive. And if you plug in 0 here, it's positive. So it's positive over positive, which gives you positive. So everything between here and here is positive. And what does that mean? When it's positive, it faces up. When it's negative, it faces down. That should be very easy for you to remember. Positive means up, negative means down. So it means whatever you're sketching in this region is going to be like this. Okay, it's positive. It can be a bowl full of positivity. Okay, positive signs. You can do it that way. Okay, now let's go from this region. Before this region, what's happening? Let's pick a number that's less than negative 1. Square root of 1, negative 1 is a good number. Plug in negative 1 here. What you're going to have is going to be 2 minus, well, if you put negative 1 here, this is going to be squared. Okay, so if you square negative 1, it becomes positive. Negative 6 times 1 gives you negative 6. 2 minus 6 gives you negative 4. So you're going to get a negative over a positive, which makes it negative. So things that are happening here are negative, which means that it's going to be something that goes this way. Okay? And this is going to be negative, 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 negative. If you do the same thing for this, let's pick a number greater than square root of 1/3. Let's pick 1. Okay, if you pick 1, put 1 here. It's the same thing. You're going to get negative answers, so it's going to go like this too. Negative, 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 negative. So you're looking at a curve that faces up between these two numbers and then faces down afterwards. So that's essentially all you need to do. We already did the trend. It's here, which also tells us that things are increasing if you go from 0. And then we now see the shape. So the concavity actually is what tells you the shape of your curve at the end of the day. So let's sketch our curve. It tells us also the horizontal asymptote says you cannot go beyond 1. So we're actually going to make these points. So this point here will be square root of 1 over 3. And make another point here, square root of 1 over 3 negative. This is the point where there is a change in concavity, so we need to recognize it just to help us sketch the curve. So it means as you're going this way, when you get here, concavity changes, and you never get to 1, you just keep approaching 1. That's all you need to do. The same thing repeats. Remember, it's an even function. So what you have here is just what you need to repeat here. Let's see how easily we can do that. Ooh, that looks beautiful. And that's your curve. You have shown the work, you have sketched the curve, and your concavity supports what you've done. You can see that this is a very important step to take for you to sketch any curve. You need to test for the concavity when it faces up and when it faces down. Everything looks justified. Okay, so look out for the other video for this one, because this one has a different kind of shape. It's even split into 2. I'll see you in the next video. If you learned something in this one, give it a thumbs up and make sure you leave a positive comment in the comment section. I'll see you in the next video. Until then, never stop learning, because those who stop learning have stopped sleeping. Bye-bye.